So hello everyone. Today we are going to discuss conic section. So we have a double nap cone. Let's say we have a cone here. This is known as upper nap and the lower part is known as the lower nap. Okay, so we can say that the double nap. So from this double nap cone, we can think about some geometrical figures. If we have a plane, let's say we have a flat sheet. So by using this flat sheet, we can make some intersection. Suppose the intersection is in this direction, then we will get a circle. If the intersection goes by this angle, then we will get an ellipse. And if we have this type of intersection, we will get a parabola. And similarly, we will get hyperbola. Besides this, if the intersection goes through the vertex of the double nap cone, then we will get just a point. Intersection goes through in this direction, then we will get two straight lines. And similarly, if the intersection just touches the outer side of the double nap cone, then we will get a single line. So the classification of conic section. Conic sections can be classified into two categories: non-degenerated conic and degenerated conic. So non-degenerated conics are circle, parabola, hyperbola, and ellipse. And degenerated conics are point, a line, or pair of straight line. So we are going to focus on parabola, hyperbola, and ellipse, and also circle. So we have to understand how to find the vertex, center, or let's say asymptotes, or how to analyze parabola, hyperbola, and ellipse. So this is our target for this lecture. So first of all, let's have a look on the general equation of second degree. So the general equation of second degree that is given here is known as the equation of conic. So it is ax squared plus 2axy plus by squared plus 2gx plus 2fy plus c equals 0. So here a, b, g, f, and c, all these are constants. These are just numbers. Okay. So based on these constants, we can understand whether the given general equation of second degree is parabola, ellipse, or hyperbola. So if AB minus AC squared is equal to 0, then we will get parabola. If AB negative AC squared is greater than 0, then we will get an ellipse. And AB negative AC squared is less than 0, then we will get hyperbola. Similarly, if A equals B and AC equals 0, then we will get circle. So these are the conditions that you have to check at first, whether the given equation is parabola, ellipse, hyperbola, or circle. And then once we understand the type of the given equation, then we can easily analyze that equation. Okay, so we have the general equation of second degree here. Have a look again. Ax squared plus 2axy plus by squared plus 2gx plus 2fy plus c equals 0. So from this equation, we have standard form of circle, parabola, ellipse, and hyperbola. So the equation of circle is x squared plus y squared equals r squared. Equation of parabola can be y squared equals 4ax or x squared equals 4ay. We may have also y squared equals minus 4ax and x squared equals minus 4ay. So there are actually 4 standard forms for parabola. Similarly, for ellipse, we have x squared divided by a squared plus y squared divided by b squared equals 1. And for hyperbola, x squared over a squared minus y squared over b squared equals 1. So we have these standard forms. Similarly, we have these forms also. So have a look here. We have x squared plus y squared equals r squared. This is the equation of circle. Similarly, x minus a squared plus y minus k squared equals r squared. This is also a circle. So the difference is, if we have this equation, then let's say this is x-axis, y-axis, then the circle will have the center at origin 0, 0, and there will be a radius. But if we have this equation, then we will get a circle, let's say here. That means the center is not at origin. The center is far away from origin. So that's why it is another standard form, but it is known as translated form. Similarly, y squared equals 4ax. If we have a parabola, let's say this one, so the vertex of the parabola is at the origin. Similarly, we may have y minus k squared equals 4ax minus k. So in that case, the vertex is not in the origin. It may be, let's say, here. So you can understand that the vertex is far away from the origin. So this is the difference between these equations and these equations. So similarly, for ellipse, we have x squared over a squared plus y squared over b squared equals 1. Here we have x squared minus, that is x minus a squared over a squared plus y minus k squared over b squared equals 1. So same thing goes for hyperbola. Have a look in these two equations. So from these equations, we have to analyze parabola, ellipse, hyperbola, or circle. So the applications of conics can be seen in science and engineering. So let's say we can see some figures here. These are the real life applications. For telescope, we have here a paraboloid shape. The glass that is used here, that is like a parabola. Similarly, the orbit of the planets are also elliptical. So these are the cases that you can see. These are the applications of conic section. So now let us move to the main section that we are going to look here. So at first,
sir,
yeah,
will the recording of this class be provided later?
I will provide the recording. Okay, don't worry.
Okay.
So at first, let's have a look on parabola. So how to analyze parabola. So we have total 4 equations. I have already mentioned here that y squared equals 4ax or x squared equals 4ay, or we may have y squared equals minus 4ax or x squared equals minus 4ay. So we have these equations. It is enough to work with these standard forms. That means standard form 1 is enough to analyze the equations. But we have to remember standard form 2 also. But to analyze any given equation that is in the general equation of second degree, we will follow the formulas of these equations. You will understand what I mean to say. So let's say we are going to discuss at first parabola. So we may have y squared equals 4ax, or we may have x squared equals 4ay. We may have y squared equals negative 4ax, or x squared equals negative 4ay. So the graph of these equations will be like this one. So y squared equals 4ax, its graph will be this type. If we have y squared equals negative 4ax, then the graph will be this one. That means for y squared equals 4ax, the open part is on the right side. And similarly, for y squared equals negative 4ax, the opening part is on the left side. So what about x squared equals 4ay? It will be of this one. So the opening side is on the upward direction, and similarly for x squared equals minus 4ay, the opening side will be in the downward direction. So these are the four graphs which are known as the standard forms of parabola. So we will just discuss about only the first two, y squared equals 4ax and x squared equals 4ay. If we can understand the formulas for y squared equals 4ax or x squared equals 4ay, then we can easily analyze this one and this one. So these two are enough. So let us have a look at first. So let me make a chart from here. We are going to analyze y squared equals 4ax and x squared equals 4ay. So the vertex. Vertex means these points. So you can easily understand that for all these equations, for all these four equations, the vertex is at the origin. So the vertex will be 0, 0 for this equation, and similarly for this equation, the vertex will be 0, 0. So this is our first formula. Next, we have to look at where is the focus. So focus will be here. There is a distance A. So this is the focus. Let's say this is F. That means focus, and V is the vertex. Similarly, for this equation, from origin to a distance A, we will get a focus F, and this is the vertex. So this point has a coordinate a, 0. Similarly, this point will have a coordinate 0, a. So the focus will be a, 0. That means x is a, y is 0. And for x squared equals 4ay, it will be 0, a. That is x equals 0 and y equals a. So next, let's have a look on the axis of symmetry. So if we have a parabola here, this will be the axis. This is also known as axis of symmetry because from this axis, whatever amount we have in the upward direction, same amount we have in the downward direction. That means this axis or this line is acting as the mirror. So this is known as axis or axis of symmetry. The graph is symmetrical about this x-axis. So you can easily see that for this parabola, y squared equals 4ax, the axis of symmetry is x-axis. So from the concept of geometry, we know that x-axis is y equals 0. The equation of x-axis is y equals 0, and the equation of y-axis is x equals 0. So since x-axis is the axis of symmetry, so its equation will be y equals 0. Similarly, let's say we have x squared equals 4ay, this equation. So for this equation, this y-axis will be the axis of symmetry. That means here axis of symmetry is y-axis, or we can say that the equation of y-axis is x equals 0. So if we have to find the equation of the given parabola, equation of axis of symmetry of the given parabola, then we have to look in these conditions. At the same time, let us have a look on another important part that is also a line, but which is known as directrix. So what is directrix? From the vertex to a distance A, we have focus. So if we consider the same distance on the negative portion on the left side, then this distance is A, but the point is here minus A comma 0 and here A comma 0. So along this point, we can think about a line, a vertical line. From this vertical line, the distance from any point P to this vertical line and the distance from any point P to the focus will be same. Okay, so this is the definition of parabola. So the equation of this directrix, this is known as directrix. So if we have to find the equation of directrix for y squared equals 4ax, then you can easily understand that this is a vertical line. The equation of vertical lines are x equals a. The equation of horizontal lines are y equals b, that are parallel to x-axis. Since directrix is a vertical line, it is going through minus a comma 0 point, so it will be x equals minus a. So the equation of directrix for y squared equals 4ax is x equals minus a. And similarly, for x squared equals 4ay, there is a directrix here. If this is a focus, then with the same distance in the downward direction, we will have a directrix. So it will be at 0 comma minus a point. That means this is a horizontal line, so its equation will be y equals b type. That means it is y equals minus a. Besides directrix, we have to find another part that is known as latus rectum. So what is latus rectum? Latus rectum is the line that is passing through the focus. That means this line. So since it is passing through the focus and this is a vertical line, it will be x equals a. That means x equals a is the latus rectum for this parabola. Similarly, for x squared equals 4ay, this will be the latus rectum because it is going through the focus. So its equation will be y equals a. So you can understand the difference between directrix and latus rectum. Directrix for y squared equals 4ax is x equals minus a, and latus rectum is x equals plus a. Similarly, for this equation, the directrix is y equals minus a and latus rectum is y equals a. We have also the length of the latus rectum. Let's say the latus rectum intersects the parabola here and here. So what is the length of this latus rectum, of this line? So it will be 4a. We can also use absolute value of 4a because length is always positive. So that's why we are using absolute value of 4a, because this distance is 2a and this distance is 2a. So total 2a plus 2a, we have 4a. So these are the formulas that we need if we have to analyze a given parabola. So suppose we have directly this equation. So that is not in standard form y squared equals 4ax. So at first, what we have to do, we have to convert this equation to the standard form. Then we can find center, vertex, let's say asymptotes, or let's say latus rectum, or axis, directrix, this. So what we have to do, at first we have to convert this type of equations to the standard form. It may be parabola, it may be ellipse, it may be hyperbola. So let us think about one equation, and then we will try to analyze that equation. The formulas are here. If the equation goes with the first equation, y squared equals 4ax, then this formula will be applied. And if the equation goes with the second equation, x squared equals 4ay, then this equation will be applied. So let us have a look. Suppose we have, let's say, y squared minus 4x minus 2y plus 5 equals 0. So at first, let us understand the type. So let's say check whether the given equation, this one, is parabola, ellipse, or hyperbola. So what we have to do? We have to compare this equation with the general equation of second degree. So the general equation of second degree is ax squared plus 2axy plus by squared plus 2gx plus 2fy plus c equal to 0. So now we have to write the given equation in this form. So we have y squared. So let us write y squared here, then x term. So there is x term here, so we are writing x here. There is y term, so negative 2y, and also there is a constant. So we have to now write this equation in this general form. So we can see that there is no x squared term, so actually we have 0 times x squared plus 2 times, there is no xy term, so the value of a is 0. We have by squared, that means we have y squared here, that means it is 1 times y squared, so the value of b is 1. So if we write by this way, 0x squared plus 2 times 0xy plus 1 y squared. Have a look on the general form, we have plus 2gx. So now to balance this and this, what we have to multiply? We have to multiply minus 2. So 2gx, the value of g is minus 2. Similarly, have a look on the general equation of second degree. We have plus 2fy. Now to balance this and the previous one, we have to multiply minus 1. So 2 times minus 1 is minus 2. So minus 2y, that is enough. Now there is a constant. So plus 5 equals 0. So you can easily understand that a is 0, ace is 0, b is 1, g is minus 2, f is minus 1, c is 5. So to understand the type of this given equation, we know that we have ab negative ace squared. So let us try to calculate this one. A is 0, b is 1, ace is also 0. So ab minus ace squared, that means 0 minus 0, that is 0. So we can see that ab minus ace squared is 0. So since ab negative ace squared equals 0, therefore let's say this is equation 1. So equation 1 is a parabola. So this is how we can compare a given equation with the general equation of second degree. So we can write here, let's say, comparing with the general equation of second degree. The general equation of second degree for conics: ax squared plus 2axy plus by squared plus 2gx plus 2fy plus c equals 0. So from this equation, we can have the values of a is b, and then we can check the type of the given equation. So now let's say we have the same equation. So from this equation, we have to find the vertex, the axis of symmetry, let's say the focus, the directrix, the length of the lattice rectum. So that means we have to analyze. So the question is, analyze the given parabola, or let's say find the vertex, the focus, the axis of symmetry, the directrix, lattice rectum for this equation. So we know that this is a parabola because this is going with AB minus AC squared equals 0. So a parabola has the standard form y squared equals 4ax or x squared equals 4ay. We know the formulas for these two equations. So since we have y squared here, so that means the equation will be similar to this one, not this one. Here we have x squared, but here we have y squared. So this will go with this form. That means the formulas that we have written here, these formulas will be applied. The formulas that are in first column are for y squared equals 4ax. So whatever equation we have here, at first we have to convert this equation to this y squared equals 4ax. So how we can convert? For this, let us have a look on the steps that we have to follow. So step 1, we have to convert the given equation to the standard form by using completing square technique. Or completing square method. So we have to convert the given equation to the standard form y squared equals 4ax or x squared equals 4ay, let's say, by using completing square method. So what is completing square? You know that if we have a plus b squared, then we know the formula is a squared plus 2ab plus b squared. Similarly, a minus b squared equals a squared minus 2ab plus b squared. So this is known as completing square method. We have this one. So we need to write a squared plus 2ab plus b squared to a plus b squared form. Similarly, this one. This is known as completing square technique. And once we have the completing square, then we have to convert the equation to the standard form anyhow. Then we can analyze. So here we have y squared. So let us try to convert this given equation to the standard form. So we are in step 1. We are writing y squared and negative 2y together. We have negative 4x plus 5 equals 0. So let's say a squared negative 2ab plus b squared. So a squared negative 2a. What we have to multiply here? We have to multiply 1 to get minus 2y. So 2ab. b is now 1. That means 1 squared. So we have taken 1 squared, that is the extra part. At the same time, subtract 1 squared. Then the equation that we have here and here are balanced. Otherwise, it will be imbalanced. Okay. So y squared negative 2y times 1 plus 1 squared, that is going with a squared minus 2ab plus b squared. And this is the extra part we have subtracted. And we have negative 4x plus 5 equals 0. So for this part, we can write by completing a square method, that is y minus 1 squared. We have negative 1, negative 4x plus 5 equals 0. So y minus 1 squared, negative 4x, negative 1 plus 5, it is plus 4 equals 0. So we have y minus 1 squared, negative 4x plus 1. 4 is the factor. So we can write here x minus 1. Negative 4 is the factor. So we have x minus 1. Now, y minus 1 squared, in step 1, it is mentioned that convert the given equation to the standard form. So we are converting the equation to the standard form for x minus 1. So our equation is y squared equals 4ax. We have also standard form 2, y minus k squared equals 4a x minus a's. Whenever we have started the session, I have mentioned to you that we have also some other forms with a's and k. Whenever we have a's and k, that means the vertex of the parabola is shifted or translated from the origin. See this figure. Or let's say for ellipse, the center is not at origin. If we have a's k, the center will be at other points except origin 0, 0. So the equation is in the standard form y minus k squared equals 4a x minus a's. You can see that here k is 1 and a's is 1, but we will not go with this equation because we don't have a look on these formulas. We have understood the formulas for this equation. So it will be wise to convert the equation to this basic form. So what we have to do? We have to write y minus 1. Let's say y minus 1 is capital Y. So y squared. We have considered y negative 1 equals uppercase Y equals 4 x minus 1 is x. So capital X equals x minus 1. Now you can see that this equation y squared equals 4x is going with 4ax, that is y squared equals 4ax. So what you can do here, we can easily analyze this equation. So y squared equals 4ax. You can easily understand that if we multiply 1 here, so this equation and this previous equation are same. So the value of a is 1. That means if we compare with y squared equals 4ax, then we have y squared equals 4ax. So here the value of a is 1. Now let us try to analyze the given equation. So we are collecting the formulas from here. If you have the formulas in your hand, then you can easily find all the informations. So at first, vertex. So the vertex is 0, 0. Since it is y squared equals 4ax, it is going with this equation, so we can apply this formula. So the vertex is 0, 0. That means x is 0, y is 0. The first value is for x, the second value is for y. So we have considered uppercase x, uppercase y. But finally, the solutions should be with small x, small y. So that's why we have to do some calculations here. So 0, 0 is the vertex. That means x equals 0, y equals 0. So capital X means x minus 1. So x minus 1 equals 0. That means x equals 1. Similarly, capital Y is y minus 1. We are just placing here y minus 1. So we are getting y equals plus 1. That means the vertex is actually at 1, 1, x, y. So the vertex is at 1, 1 point. This is 1, this is 1. So the vertex is at 1, 1 point. And the parabola will look like this form. So vertex is done. Now let us find the focus. So for focus, the formula is a, 0. That means capital X is a and capital Y equals 0. This is x, this is y. Now we have to place the term for capital X. It is small x minus 1. And what is the value of a? A is 1. Okay, because a is found from 4ax. So a is 1. That means we have x equals 1 plus 1. That is x equals plus 2. Y, capital Y. We have small y minus 1 for the uppercase y. So let us write here small y minus 1 equals 0. That means y equals 1. So you can easily see that the focus will be x, y, 2, 1. So we have found also the focus. That means the vertex is at 1, 1 point and the focus is at 2, 1 point. Okay, so this is how we can think about the parabola. So the focus is done. Now axis of symmetry. Axis of symmetry. So for y squared equals 4ax, the axis of symmetry is x-axis or y equals 0. That means here capital Y equals 0. Okay. So capital Y means small y minus 1 equals 0. So y equals 1 is the axis of symmetry. You can see from here. This is y equals 1. So this is the axis of symmetry. Whatever amount we have above y equals 1, same amount we have at the below portion. Okay, so that's why this is the axis of symmetry. So axis of symmetry is also found. Now let us find the directrix. So the directrix formula is x equals minus a. That means equation of directrix. The formula says that it is x equals minus a. So uppercase X, it is small x minus 1 and A is 1. Uppercase X is x minus 1 and there is a negative here, A is 1. So we are getting x equals negative 1 plus 1. That means x equals 0. So x equals 0 is the directrix. X equals 0 means y-axis. So this is the vertex. You can easily understand that this is the vertex, this is the focus, and this is the directrix. Now, latus rectum. Latus rectum means the equation that goes through the focus. So the latus rectum's equation is x equals a and its length is 4a. So let us also find the equation of latus rectum. So the equation of latus rectum, it is x equals plus a and its length will be 4a. So it is small x minus 1, a is 1. So we have x equals 1 plus 1, that is x equals 2. So x equals 2, this equation is the latus rectum and the length will be from this point to this point. So the length will be length of latus rectum LR is equal to modulus of 4a, that is 4 times 1, that is 4. You know that absolute value of 4 equals 4. So this is the length of the latus rectum. So finally, we have learned how to analyze any given equation that is in the general equation of second degree form. So if we have this type of equations, then our first target should be to convert to the standard form, either y squared equals 4ax or x squared equals 4ay by using completing square method. And then we can apply the formulas. So this is about parabola. Similarly, we can think about ellipse and hyperbola. So let us move to ellipse. Equation of ellipse. Okay, at first we can have a look on the graph of y squared minus 4x minus 2y plus 5 equals 0. I have already drawn the graph here. You can see y squared minus 4x minus 2y plus 5 equals 0. So this is the vertex. This is at 1, 1 point. We have also found that the vertex is at 1, 1. Now focus will be at 2, 1 point. The focus will be here. You can see this is the focus. This point is the focus. And from focus, we will have the equation of latus rectum. The latus rectum will be at x equals 2. So if we draw x equals 2, then you will get the latus rectum. We have the directrix. The directrix is at x equals 0. So let us draw x equals 0. This black color line is the directrix. What is our axis of symmetry? We have found that the axis of symmetry is y equals 1. So let us draw y equals 1, y equals 1. So this point is the focus. This is the vertex. So you can see how to draw parabola and how to analyze parabola. Let us now have a look on ellipse similarly. So ellipse can be x squared over a squared plus y squared over b squared equals 1. We may have also x minus a squared over a squared plus y minus k squared over b squared equals 1. So sometimes a is greater than b. This a is greater than b. Sometimes a is less than b. And we have the same equations. So we can think about one example. Let's say x squared over 2 squared plus y squared over 3 squared equals 1. So you can understand that a equals 2, b equals 3. So a is less than b. Similarly, we can think about x squared equals 4 squared plus y squared over 2 squared equals 1. So this is a, this is b. So a is greater than b. So if we have a greater than b, then the graph of the ellipse will look like this one. This distance is a, this distance is also a, this distance is b, this distance is b. And if we have a less than b, then the graph of the ellipse will be of this shape. Since b is greater than a, so this is b, this is b, and this is a, this is a. So these are the differences that we have in ellipse. So we are not going through these two equations. We will have a look on the formulas of this equation and this equation. Sometimes a is greater than b and sometimes a is less than b. So what will be the formulas? So at first, let us try to have a look on ellipse, the graph of an ellipse. We have suppose x squared over a squared plus y squared over b squared equals 1. Try to understand the graph of the ellipse. So this is a comma 0 point. This is minus a comma 0 point. And let's say this is 0 comma b point. And this is 0 comma minus b point. So we have total 4 points. These are known as the vertices. So the vertices, we have vertex 1, vertex 2, vertex 3, vertex 4. So a0 minus a0 are known as the main vertex. So these are the main vertices, and 0 comma b and 0 comma minus b are known as co-vertices. Okay, so we can draw the graph of the ellipse. So this is what ellipse is. We have total 4 points. These are known as the vertex. Vertex 1, vertex 2, vertex 3, vertex 4. So this is the ellipse. You can see that here, this is the center. So the center is at origin 0, 0. Just like parabola, ellipse has also focus. Let's say this is focus. There is another focus here. For parabola, we have only one focus, but for ellipse, we have two focus. So we can say that foci. Foci is the plural form of focus. Okay, so we have total 2 focus, f1, f2. The equation of x-axis is, y equals 0. But this equation, that is y equals 0, or this axis is known as the major axis. So major axis for an ellipse where a is greater than b is the x-axis. And y-axis is the minor axis. Y-axis equation is x equals 0. So minor axis is the y-axis. Now, what is the length of the major axis? So you can see that this distance is a, and this distance is also a. So the length of the major axis will be 2a. Similarly, what is the length of the minor axis? This distance is b, this distance is also b. So the length of the minor axis is 2b. So these are the informations that we are collecting from this ellipse, and the line that passes through the focus are known as the lattice rectum, LR. There are two lattice rectums here, first one and second one. There is a term here, eccentricity. Eccentricity is denoted by E. E is sometimes 1. If E is 1, then we will get parabola. If E is greater than 1, then we will get hyperbola. If E is less than 1 and greater than 0, then we will get ellipse. So we will talk about eccentricity later, but for now, try to have a look on the graph of the ellipse. We can also have directrix. So there are two directrix here, directrix 1, directrix 2. So we can say that there are two directrices. Now let's have a look on the formulas of ellipse. So we have, let's say, x squared over a squared plus y squared over b squared equals 1. Here a is greater than b. So at first, center, x squared over a squared plus y squared over b squared equals 1. Here a is greater than b. So the center for this ellipse is 0, 0. Then focus. We can say foci. There are two focus of an ellipse, so we can say foci. So the foci will be at plus minus AE, 0. So what is E? E is the eccentricity. So for ellipse, E is less than 1 but greater than 0. For parabola, E is equal to 1. For hyperbola, E is greater than 1. So we need this condition, E is less than 1 and greater than 0, because we are discussing ellipse now. So the formula for ellipse is E equals square root of a squared minus b squared over a squared. So if we have E, then we can easily multiply A with E. We will get AE. Plus AE and minus AE can be found after having E in our hand. So this is about foci. Then we have the vertices. We have seen that the vertices are at plus A0 minus A0, plus 0, b, and 0, minus b. So what we can write here? We can write that plus minus a, 0, a, 0 and minus a, 0. Also, we can write 0, plus minus b, 0, b and 0, minus b. These are the main vertex and these are the co-vertex. That is main vertices and co-vertices. So after vertices, we can think about the axis of symmetry. So there are two axes, that is major axis and minor axis. So let us have a look on major axis. So I have mentioned to you that the major axis will be x-axis, that means its equation is y equals 0, and the minor axis is y-axis, its equation will be x equals 0. So the major axis is x-axis, that means y equals 0. Also, let us write the length. The length of the major axis is 2a. What about minor axis? Minor axis will be the y-axis. that is x equals 0. So it will be 2b, that is the length. Now, after axis, we can think about the length of the lattice rectum. So the length of the lattice rectum for this ellipse is 2b squared over a. You have to remember this formula. The formula is 2b squared over a. And the formula for directrix. So there are two directrix, so we can say that directrices. So the directrices will be at x equals plus minus a divided by e. We have e in our hand and we have a, so a over e will be one directrix and minus a over e will be another directrix. So this is about this x squared over a squared plus y squared over b squared equals 1. Similarly, we can think about the formulas of the other ellipse that we have. It is, let's say, x squared over a squared plus y squared over b squared equals 1, where a is less than b. And the formula that we have seen, these are for a is greater than b. So for this equation, the center is again same, it is 0, 0. The foci will be different. It will be 0, comma plus minus BE. But this time, the formula for eccentricity is also different. Let me write. E will be square root of b squared minus a squared over b squared. So this is for a less than b, and this one is for a greater than b. So if we have e, then we can multiply with b, you will get be. So 0 comma be and 0 comma minus be is the foci. Now we can write the vertices. So the vertices will be 0 comma plus minus b and plus minus a comma 0. That means you can see that same coordinates are here, but this time these are the main coordinates, which are the main vertices, and these are the co-vertices. And here these are the main vertices and these are the co-vertices. Okay, then axis. If we have an ellipse like this form, so this will be now the major axis. So the major axis will be y-axis, that is x equals 0, and the minor axis will be the x-axis, y equals 0, and the length of major axis will be 2b, and the length of the minor axis will be 2a. So you can see that whatever formula we have earlier, so this time the formulas are different. These are looking reversed form. So here we have plus minus a0, here we have 0 plus minus b. Here we have y equals 0, here we have x equals 0. X equals 0, y equals 0. So this is how you can remember the formulas. And the equation of directrix, that is the directrices are at x equals plus minus a over e. So this is for x squared plus x squared by a squared plus y squared by b squared equals 1, where a is greater than b. For a is less than b, it will be y equals plus minus b over e, and the length of the lattice rectum will be 2a squared over b. So at the same time, let us write the eccentricities. eccentricity for a greater than b will be this one. So E equals square root of a squared minus b squared over a squared, and E equals square root of b squared minus a squared over b squared. So this is eccentricity. So now we can think about any equation. For that equation, we have to analyze or find all these informations. So you need to remember this table. If you can remember these formulas, then we can analyze any given equation if the equation is an ellipse. So let's say at first we have an equation. Check the type of the following equation. So the equation is x squared plus 4x plus 4y squared minus 8y plus 4 equals 0. So if we have this equation, then at first we have to understand the type. Is it parabola, ellipse, hyperbola? We have to think about again the general equation of second degree. Ax squared plus 2axy plus by squared plus 2gx plus 2fy plus c equals 0. So if we have this equation, so we need to make this equation similar to this one. So that means we have to rearrange the given equation. So what we can do, we can write, let's say 1x squared plus, there is no xy term, so 2 times 0 xy plus by squared, that means 4y squared. So this term is done, and then x, so we have 4x. That means to compare with the general equation, we are writing 2 times something x, so that means 2gx, g will be 2, then we are getting 4x. So this is how we have to balance the next equation and the previous equation. Now plus 2fy, so plus 2fy, so to get minus 8y, we have to multiply minus 4. So that means we have now minus 8, and we have plus 4 equals 0. So you can understand that what we have done here, we have just compared the given equation with the general equation of second degree. So we can write comparing with the general equation of second degree. So we are getting a equals 1, ax squared plus 2axy plus by squared plus 2gx plus 2fy plus c. So a equals 1, a is equals 0, b equals 4, a is b, g, f, c. A is b. These three informations are needed only. So 4 minus 0, that is 4. 4 is greater than 0. That means you can see that ab minus x squared is greater than 0. So since ab negative h squared is greater than 0, therefore let's say this is equation 1. So equation 1 is an ellipse. If we have an ellipse, so what we can do, we can now analyze. So first of all, let us find all the informations. We need center, foci, vertices, axis, major axis, minor axis, and also its length. Then let us rectum, directrices, eccentricity, etc. So the equation that is here, that is not in standard form. Okay. So what we have to do, we have to convert this equation to the standard form by completing square technique. So x squared plus 4x, this part is written together, and 4y squared negative 8y, we are writing this y terms together, and we have 4, that is the constant. Now x squared, let's say x is a squared plus 2a, b should be 2, then we are getting 4x. So x squared plus 2ab plus b squared. So we have added 2 squared. At the same time, we are subtracting 2 squared. Then this and these are cancelled, you are getting the same thing. So the previous equation and the new equation is now balanced. And now for this, what we can do, we can just take 4 before. Let's say 4 is factored out. So we have y squared minus 2y. 4y squared minus 8y can be written as 4 times y squared minus 2y. So here, y squared, that is a squared minus 2a, b should be 1. Then we are getting negative 2y. Now plus 1 squared. So actually it is looking like 1 squared, but we have total 4 times 1 squared, that is 4. We have added 4. That means we need to subtract 4. Then this equation and this equation is balanced. Try to have a look again. We have 1 squared, 1 times 4. That means we have extra 4. So to subtract that, we have added minus 4. And we have plus 4 also equals 0. So up to this part, we can write x plus 2 squared. Then we have minus 4. Then 4 times, we can write y minus 1 squared. Then we have minus 4. And we have plus 4 equal to 0. So now you can see that 4 and 4 cancelled. We have x plus 2 squared plus 4y minus 1 squared, and we can transfer negative 4 on the right side. We are getting positive 4. So this is obviously will be an ellipse if we write by this way: x plus 2 squared plus 4 y minus 1 squared equals 1. So x plus 2 squared divided by 4 plus 4 times y minus 1 squared divided by 4 equals 1. Okay, we have just written the previous equation in a new form. Okay, we have just separated the terms. So we can see that this 4 and 4 can be cancelled. We have just 1 here. So next we have x plus 2 squared divided by 4 plus y minus 1 squared divided by 1 equals 1. Or we can write x plus 2 squared divided by 2 squared plus y minus 1 squared divided by 1 squared equals 1. So you can now compare with the standard forms that we have: x minus a squared divided by a squared plus y minus k squared divided by b squared equals 1. This is with this condition a is greater than b. You can see that a is 2 and b is 1. So this time a is greater than b. So the equation is going with this standard form, but we have just learned the formulas for x squared over a squared plus y squared over b squared equals 1. So what we can do, we can think that this x plus 2 is capital X and y minus 1 is capital Y. So automatically we will have this equation, and then the formula for this equation will be applied to get all the information. So we are considering here capital X squared over 2 squared plus capital Y squared over 1 squared equals 1. So that means we have considered uppercase X equals small x plus 2, and small y minus 1 is considered as capital Y. Also we have a equals 2 and we have b equals 1. So since a is greater than b, so these formulas will be applied. The formulas that are in first column will be applied. So center is 0, 0, foci is plus minus a, comma 0, vertices are plus minus a, comma 0, 0, comma plus minus b, major axis are x-axis and minor axis is y-axis. So y equals 0 and x equals 0 are the major and minor axis. Latest rectum, its length will be 2b squared over a. Directrices will be x equals plus minus a over e, and eccentricity will be e equals square root of a squared minus b squared over a squared. So let us at first find the eccentricity. Eccentricity e for a greater than b, it is a squared minus b squared over a squared. So we have to just place the values of a, b. So a is 2, that means 2 squared minus 1 squared over 2 squared. So we are getting 4 minus 1 over 4. That means e equals square root of 3 over 4. So e equals square root of 3 over 2. So this is e. Now, once we have e, we can find foci, then center, vertices, everything. So you can see that e will be less than 1 but greater than 0. If we find the numerical value of square root of 3 over 2, it will be in between 0 and 1. So that means based on this value, we can understand that the given equation is an ellipse. But we have already understood the type from this formula. AB minus AC squared equals 4, that is greater than 0. So that means this is also an ellipse. So now let us find all the informations. First, center. So center is the origin, 0, 0. That means x equals 0, y equals 0. So from this capital X and capital Y, we have to find small x and small y values. So capital X is x plus 2. And capital Y is y minus 1. So from here we can see x is minus 2, y is 1. So that means the center is at minus 2, 1. X, y. X is minus 2, y is 1. So the center has been found. Now, foci. Foci means there are two focus we have. So foci will be plus minus AE, comma 0. So the first part is for x, the second part is for y. So x equals plus minus AE and y equals 0. So x plus 2 equals plus minus a. The value of a is 2. And e is square root of 3 over 2. So we are getting x plus 2 equals plus minus square root of 3. So if we work with plus, we will get minus 2 plus root 3. And if we work with minus, we will get minus 2 minus root 3. So there are two values of x here. So you can find all that two values, but you can also keep your answer in this form, x. Similarly, y minus 1 equals 0, so y equals 1. So we have found also y. So the foci will be at minus 2 plus minus root 3. This is x comma y. So you can find the decimal values. There will be 2 points, that is 2 focus. First will be for plus and the second will be for the minus. Okay, so foci have been found. Now let us find the vertices. So the main vertices are plus minus a comma 0, and the co-vertices are 0 comma plus minus b. So x equals plus minus a, y equals 0, x equals 0, and y equals plus minus b. So there will be total 4 points. So x, that is capital X, is x plus 2 equals plus minus a. A means 2 and b is 1. Y is y minus 1 equals 0. Similarly here, x plus 2 equals 0, and y minus 1 equals plus minus b. That means b is 1. Yeah. So we can now find the vertices. X equals minus 2 plus minus 2, comma y equals 1. So if we take these points, we will have minus 2 plus minus 2, comma 1. That means if we take plus, it will be 0, 0, 1. And if we take minus, we will get minus 4, comma 1. So I hope you have understood what I mean to say. That means you can find numerical values. Okay. Okay, let me find the numerical values. If we work with plus, that means we are getting for plus, we have x equals minus 2 plus 2, this plus. So we have actually 0. So x equals 0, y equals 1 is the first point. For minus, x equals minus 2 minus 2. That means x equals minus 4. So x equals minus 4, y equals 1. This is another point. So these are the main vertex. First vertex, second vertex. Similarly here, x equals minus 2 and y equals plus 1 plus minus 1. So if we work with plus, then y equals minus plus 1 plus 1. That means we are getting y equals plus 2. So the point will be xy, that is minus 2 comma 2. If we work with minus, then y equals 1 minus 1. That means y is 0. So the point will be xy minus 2, 0. So these are also the vertex. This is known as co-vertex. This is another co-vertex. So these are the total 4 vertices that we have for the given ellipse. And now let us find the axis. So we have the major axis. We have also the minor axis. So if we have the major axis, then it will be y equals 0, major axis is just x-axis, minor axis is y-axis. So the formula says that it is y equals 0, but for our case it will be capital Y equals 0, and minor axis is x equals 0, but for our case it will be capital X equals 0. So now let us input capital Y. It is small y minus 1 equals 0. So y equals 1. Capital X is small x plus 2. So that means we have x equals minus 2. So this is the major axis. This is the minor axis. We can also find the length of the major axis. We know that its length will be 2a. That means 2 times a is 2. So 2 times 2, that is 4. So this is the length of major axis. If we have to find the length of the minor axis, then the formula says that it is 2b. So 2 times b is 1. So 2 times 1 is 2. So this is the length of the minor axis. So this is also done. Now the length of the lattice rectum. So the length of the lattice rectum is 2b squared over a. So 2 times b, we know it is 1, and a is 2. A is 2. Yeah. So we are getting 2 over 2. That is the length of the lattice rectum is 1. And finally, let us find the equation of directrix. That is equation of directrices. Since there are 2 directrices for an ellipse, we can think about its formula, that it is x equals plus minus a divided by e. Have a look here. X equals plus minus a divided by e. For our case, we have to consider capital X. So capital X is small x plus 2. Small x plus 2 equals plus minus a. A is 2. And e, we have found e is square root of 3 over 2. So square root of 3 over 2. So x plus 2 equals plus minus 2 times 2 over square root of 3. That is x plus 2 equals plus minus 4 over square root of 3. So we can write x equals minus 2 plus minus 4 over square root of 3. That means if we work with plus, we will get x equals minus 2 plus 4 divided by root 3. You will get the numerical value. If we work with minus, x equals minus 2 minus 4 over root 3. So this is first directrix and this is the second directrix. So this is how we can analyze an ellipse. So let us have a look on the graph of this ellipse. You can see we have the graph of the ellipse: x squared plus 4x plus 4y squared minus 8y plus 4. So whatever we have found that the center will be at minus 2, 1. Okay, the center will be at minus 2, 1. You can see we have the center at minus 2, 1 point. Similarly, the foci is at minus 2 plus root 3, 1 and minus 2 minus root 3 comma 1. So this will be also here and here. Now let us have a look on the vertices. The vertices will be at 0 1 minus 4 1 0 1. This is minus 4 1, you can see, and another two vertices are minus 2 2 and minus 2 0, minus 2 0 and minus 2 2. So all the vertex are here. So the vertices, we can see the vertices here, and by our analytical method we have found all the vertices. Major axis is y equals 1. So if we draw y equals 1, this is the major axis, you can see. Minor axis, x equals minus 2. We have found x equals minus 2. Let us see. Yeah, we have the minor axis. And this is the center. The center is at minus 2 comma 1 point. The center is at minus 2 comma 1 point. And equation of directrices, it will be x equals minus 2 plus 4 over root 3. X equals minus 2 minus 4 over root 3. So if we have the decimal values, we can also think about the directrices here. So this is how we can analyze an ellipse. So similarly we can think about hyperbola. So for hyperbola, I will not solve any problem, but I am giving the formulas here. So just like ellipse, we have an equation of hyperbola, x squared over a squared minus y squared over b squared equals 1. So this is the first hyperbola. We may have also another hyperbola, x squared over a squared. Let me write this one again. Y squared over b squared minus x squared over a squared equals 1. So we have these two forms. These are known as standard forms. Also, we can think about x minus a squared over a squared minus y minus k squared over b squared equals 1. Similarly, for this equation, we have y minus k squared over b squared minus x minus a squared over a squared equals 1. So if we know the formulas for these two equations, then we can easily analyze this and this. These are the standard form 2 and these are standard form 1. I have mentioned at the very beginning that there are two standard forms, standard form 1, standard form 2. So if we have a standard form 2 with k, then these are translated equations. That means the center, the vertex will not be at the origin. It will be shifted from origin. So let us have a look on the formulas for these two equations. So equation of hyperbola. Suppose we have x-axis and y-axis here. So from center 0 0 to a point a0, from center 0 0 to another point negative a0. So these two will be the vertices of the hyperbola. Similarly, we can think about 0 comma b, 0 comma minus b, but before let us draw the graph. The hyperbola will look like this shape. So this is vertex 1, vertex 2. If we have the vertex, then we must have the focus. So focus 1, focus 2. From focus we have latus rectum. From focus we have latus rectum. And now the distance that we have here On the opposite side, with the same distance, we will get the equation of directrix. This is a line, so directrix 1. Similarly, whatever distance we have here, if we come with the same distance in opposite side, we will get a directrix. So let's say this is directrix 2, and the axis that we can see here, the x-axis is known as the transverse axis. Transverse axis. And this y-axis is known as the conjugate axis. For ellipse, we have learned that this axis is known as major axis and the vertical axis is known as minor axis. But for hyperbola, we have transverse axis and conjugate axis. Okay, so at the same time, we should remember another two things, that is, hyperbola have asymptotes. Asymptotes are lines that are looking like this. That means at infinity distance, we can think that this line and this yellow color curve are touching each other, but actually they are not touching. Okay, there is no intersecting point at infinity distance. Always there will be a gap here. So this type of lines are known as asymptotes. So similarly, we have another asymptotes here. So first asymptote and the second asymptote. So there are two asymptotes. Now, let us come to the point B. We have x squared over a squared minus y squared over b squared equals 1. So we have found where we have a. So this is a comma 0. This is minus a comma 0. Similarly, we can think about now b. So b will be, if we make a vertical line here from this vertex, there is an intersecting point. We have an intersecting point here. Similarly, we have an intersecting point here. So now these two intersecting points can be joined. So this point will be 0 comma b. Similarly, we can make a vertical line to the downward asymptote, and similarly there is a vertical line to the downward asymptote, and we can join these two points. So this point will be 0 comma minus b. So for ellipse, we can easily understand that 0 comma b and 0 comma minus b are here and here. But for hyperbola, we have to think about asymptote at first, and then we can find the distance b. So 0 comma b, 0 comma minus b. So only v1 and v2 will be the vertices this time, because this point and this point are not the vertices, because these are not on the hyperbolas. Okay, so let us now write all the formulas. So at first we are writing the formulas for x squared over a squared plus y minus y squared over b squared equals 1, and then we will write y squared over b squared minus x squared over a squared equals 1. So at first, center will be at 0 0 for both cases. Then foci, there are two focus here, focus 1, focus 2. So foci will be plus minus ae comma 0, and for this one it will be 0 comma plus minus be. That means just same as ellipse, but the only difference that we have here, the difference is in the eccentricity. E equals square root of a squared plus b squared over a squared for the first case, and for the second case E equals square root of a squared plus b squared over a squared. So once we have E, then we can easily find AE, or let's say BE. So automatically we will get foci. Now equation of the axis, let's say at first we have transverse axis. I have mentioned to you that the first axis that we have here, it is known as transverse axis, and the second axis is y-axis or the conjugate axis. So equation of transverse axis. Transverse axis is x-axis. That means x-axis equation is y equals 0 and its length will be 2a. Remember, the length will be 2a because this distance is a and this distance is also a. So total 2a, and the length of the minor axis is b plus b, total 2b, and minor axis this time is known as conjugate axis. So the equation of conjugate axis will be x equals 0 because it is y-axis. So conjugate axis, it is y-axis or x equals 0 and the length will be 2b. Similarly, for the second equation, y squared over b squared minus x squared over a squared equals 1, the transverse axis will be y-axis. That means for these two hyperbolas, the formulas are interchanged. Y-axis means x equals 0 and its length will be 2b. Similarly, conjugate axis will be x-axis or y equals 0 and its length will be 2a. Now, the formula for the length of, let us, rectum. So length of, let us, rectum, it will be 2b squared over a for the first case, and for the second case it will be 2a squared over b. Now directrix, there will be two directrix here, so we can say that directrices, so it will be at x equals plus minus a over e, and for the second case we have y equals plus minus b over e. So you can understand that whatever formulas we are writing here that are similar to ellipse. For ellipse we have written x equals plus minus a over e, and for the second type we have written y equals plus minus b over e. So all the formulas are same, but only the difference is found in eccentricity. Eccentricity for ellipse is this one, and eccentricity for hyperbola is given here. So besides all these informations, we need another information, that is what will be the equation of this asymptotes. So equation of asymptotes. it will be y equals plus minus b divided by a x. That means this will be y equals plus b over ax, and this will be y equals minus b over ax. So y equals plus minus b over ax. And similarly, for the second hyperbola, the equation of asymptotes will be y equals plus minus a over b x. So if you have all these formulas, then you can easily analyze any hyperbola. Let's say we have x squared minus y squared minus 2x minus 2y minus 1 equals 0. If we have to understand the type of this equation, this is the general equation of second degree. It is going with ax squared plus 2axy plus by squared plus 2gx plus 2fy plus c equals 0. So from this equation, the equation that we have to compare this equation with the general equation of second degree. Then we will get a is b. We will also have g f c. So once we have all the values, then we will check ab minus ac squared. If this is equal to 0, then parabola. If this is greater than 0, then ellipse. If this is less than 0, then we will get hyperbola. So the equation that is given, it is in the general form. It is not in standard form. So to convert this to standard form, we have to apply completing square technique. But this time I am not going to solve this one. This is similar to the previous problems. You can convert the equation to any of the standard form, and then you can think about that this is capital X, so x squared, capital y squared. So automatically you will have all the information: center, foci, axis, eccentricity, like that. So let us directly have a look on the graph of this equation. X squared minus y squared minus 2x minus 2y minus 1. X squared minus y squared minus 2x minus 2y minus 1 equal to 0. So this is the hyperbola. We have first branch, we have the second branch, and the vertex is 0 minus 1 and 2 minus 1. So automatically the center will be here, and this line will be the transverse axis. That means y equals minus 1 will be the transverse axis. You can see this is the transverse axis, and x equals 1 will be the conjugate axis. Okay, so this is how we can analyze conic. So these are the cases that we have to learn from conic sections. So another thing that we have to discuss, that is circle. So for circle, let's say we have x squared plus y squared equals r squared. This is the standard form 1. We have also x minus a squared plus y minus k squared equals r squared. This is standard form 2. So for this circle, the center of the circle will be at 0, 0, and the radius will be r. For this circle, the center will be at h, k, and the radius will be r. So if we recall the general equation of second degree, x squared plus 2axy plus by squared plus 2gx plus 2fy plus c equals 0. So this equation will represent a circle if a equals b and h equals 0. Then you will get an equation of circle, either this one or this one. So there is an alternative version of the general equation of second degree. If we can understand that this equation is representing equation of circle, then we can also write another equation: x squared plus y squared plus 2gx plus 2fy plus c equals 0. So this is also another form of circle. So we can think about all these equations. So let's say we have x minus 2 squared plus y minus 1 squared equals 4. So this is an equation of circle, because if we write this one as x minus 2 squared plus y minus 1 squared equals 2 squared, then the center is 2 1 and the radius is 2. So this is x-axis, this is y-axis. So let us look at the center. Center is at 2 1 1 2 1 2. So 2 1 point will be here. Radius is 2. So 1 2. If we take this distance, 1 2 1 2 1 2. So we can easily draw the graph of the circle. Okay. So the radius is 2 and the center is at 2 1. So this is what you have to know about circle, but the important parts are parabola, ellipse and hyperbola. So that's all for today. Thank you.